Hey guys, good day to all. Okay, so we are in our part 2 already of our static lateral force procedure, and this will also serve as the continuation of our last time's discussion. Okay, so let us proceed, guys. So next is the response function, response modification factor R. Okay, so building a structure to respond 100% elastically in a large magnitude earthquake would not be economical. Okay, so dili siya economical, guys. So since it requires big na mga big dimensions of our members na in order to resist earthquake. And sometimes mahal dyan na siya no pag dako kayo ang mga members sa building. Okay? Strength reductions due to nonlinear behavior are influenced by the maximum allowable displacement ductility demand. Okay, so the fundamental period of the system and the soil profile type. Strength reductions from the elastic strength are accomplished by using a response modification factor. Okay, the structure response modification factor R represents the inherent over strength and global ductility capacity of structural components. Okay, so overstrength na word, guys, will be defined later. And I think always no sa atong structure mo gyud natong gusto may tawo, guys, na may mo siyang ductile ang atong design. Okay, so ductility can be defined as a measure of ability of the structural system to deform in plastic range prior to failure. Okay, so mo na yung gusto. At least ma-deform siya before mag-fail. Kay para na ay warning, no? Na mga warning sa mga occupants. Okay, so ductile performance is important because seismic energy is dissipated through yielding of the structural components, and because it permits considerable displacements during intense earthquake without risk to the structure's integrity and the occupant's life safety. Okay, so mo na ang iyang mga kuan. O gusto ba niya na mag-yield na through yielding? Okay, ang meaning sa yielding, guys, is the ability of the material to elongate or na deformation, no, pero dili na mo balik sa original form. Okay, pag once magud na mag-yield, guys, so nanay mga mga displacement, mga considerable na displacement, then kana siya is makita na dayon sa mga occupants na oy mura naga-deform siya or na mga displacement, so at least na early warning. Okay, so mo to kung as stated ganina na katong sa ductility na part. Okay, so the structure response modification factor is determined from the type of structural system used in design of structure. So as defined for buildings in UBC 97 table 16-N, and for non-building structures in UBC 97 table 16-P. Okay, so mo na atong basis, guys, for getting this R value, no, kaning type of structural system na gamitan, no, para sa to ang structure. Then systems with higher ductility, say for example steel moment resisting frames, have higher R values associated with better seismic performance expectations. Okay, so mo na, guys, so kung taas ang R, meaning taas po ang ductility rate, no? So makita na to na later sa table. Okay, so kung naay response modification factor, na po seismic force amplification factor, guys, or omega, no, omega sub O. Okay, so the type of structural system and natural period of a structure significantly influence the structure's response to the ground shaking. Okay, so kay depende magila guys kung yun sa pag-construct kung sa na klase na structural system. Then kaning period later pala to ni ma-discuss guys no kung sa ginang period. Mao na sila ang mga isa sa mga basihan no sa response sa building. Okay, so now we will define the word overstrength. So overstrength is defined as characteristics of structures where the actual strength is greater than the design strength. Okay, so mauna ha. So actual strength is greater than greater than design strength. So overstrength tawag. So the degree of overstrength depends on material type and structural system type. Okay, so a seismic force amplification factor, or also called as overstrength factor guys, has been assigned to each identified structural system. So this factor accounts for overstrength of structure in the inelastic range. Okay, so para nakay ko na murag sobra no, sobra na strength pag once mag-abot ka dito sa inelastic range kay tulo man na guys. Elastic, inelastic and plastic range magandang mga stages na ma-experience atong structure. Okay, so structural system. So the UBC 97 recognize 7. Okay, so 7 major types of structural systems capable of resisting lateral forces. In determining the base shear and design story drift for the structural systems mentioned, UBC 97 table 16-N provides corresponding height limits as well, no? So napo dito ang R guys and also the katong omega O. Okay, so non-building structures are defined in UBC 97 as well. Pero mas concerned na to ang building structures it guys. Okay, so isa-isaw na to guys. So ila-ilaw na to tong 7. Okay, 7 major types of structural systems. Okay, so ako siya introduce sa inyo before na to ipakita ang table. Okay, so first guys is the bearing wall systems. Okay, so a bearing wall system is a structural system that relies on same elements to resist both gravity and lateral loads. Okay. So by itself, the word wall is ambiguous because there are two main types of structural walls, wherein those walls are partition walls and curtain walls, and these are not structural walls no mga kuan dili na sila mo resisted kayo og mga loadings. Okay, so partition lang gud no for partition purposes. So a bearing wall is designed and constructed to resist vertical loads. Okay, so mao na yung mga kuan makita sa mga buildings. So napoy mga inana guys, mga bearing wall. So a shear wall, no, napoy shear wall is designed and constructed to resist lateral loads. Okay, so a wall can be used to resist both vertical and lateral loads. So a bearing wall system does not have a complete vertical load carrying space frame. Bearing walls or bracing system support all of the gravity load. The lateral forces are resisted by shear walls, light bracing in bearing walls or braced frame. The bearing wall system lacks redundancy and has an inadequate inelastic response capacity. So such systems do not possess a complete vertical load carrying frame and rely on walls or braces frames to carry the vertical and lateral loads, specifically the seismic. So the distinguished factor of this system is that the failure of the primary seismic loads also compromises the ability of the structure to support its dead load and live loads. Okay, so mao tong kuan guys. Mao to ang mga keyword diri sa bearing walls no. It largely depends sa walls kid. Okay. Pero kung tas mga braced frame, so murag wala ni siya postehay no kung sa kuan. Kay murag ang iyahang gusto man god is ang bearing wall mo carry sa gravity load, no? Then ang shear wall ang ipaload sa ang iparesist sa lateral loads. Okay? lacks redundancy, no, mo to guys, lacks redundancy or kulang og mga support, no, kay puro, imagine nimo na puro lang good walls, no, kana siya. So this is the typical image guys sa bearing wall. So typical bearing wall systems are light frame walls with shear panels, concrete or masonry shear walls, light steel frame bearing walls with tension only braces, and brace frames where the bracing carries the gravity load. So kana guys, wala na postehay na, puro na siya walls tanan kana. Kana wala man na poste, walls lagi na siya. Okay, kana siya. Then dapat kana siya na structure will resist both gravity and lateral. Second is building frame system. So a building frame or vertical load carrying frame is a complete self-contained three-dimensional unit composed of interconnected members. The building frame systems use a complete space frame to carry the vertical loads and a separate system of non-bearing shear walls or braced frames to resist the lateral load. So unlike the bearing wall system, failure of the primary lateral support system does not compromise the ability of the material to support gravity loads. Okay, so muna guys, no, mga brace building frame naman yang na. So the requirements of the deformation compatibility of UBC 97 provision should be satisfied for this system. The frame may or may not have bracing. If it does, it's known as a braced frame. A braced frame is a vertical truss system of interconnected members designed to resist lateral loads through the development of axial loads in the member. So braced frames can be of the concentric or eccentric types that are relatively rigid and requires special detailing to ensure adequate ductile performance. Okay, so mawala na problema guys na pag na yung mga paraan yung mga braced frame, no, so rigid, usually rigid, and dili kaya nato na ginakuha. So gahi gid guys, no, gahi gid ang structure, pero ang assurance sa na ductile performance kay basig dili ma-achieve na. So mao na ang problema sa kung rigid kayo ang structure. So mao na usually gina-allow gyud na mag-move in eye movement, but considerable ang pod, no, dapat ma-consider pod na kuan kanang acceptable ang iyahang kuan ang movement. So typical building frame systems are steel eccentrically braced frames, light frame walls with shear panels, concrete or masonry shear walls, steel, concrete or heavy ordinary braced frame, and special steel concentrically braced frame. So inani guys. So nanay framing, nanay mga framing guys kana. Okay, so nanay framing. So nanay columns, nanay beams, then nanapog kay shear wall. Okay. Okay, nanay mga shear walls. Ito. Then now is moment resisting frames. Kani po dali guys sa kuan dali po sa building frame systems is pwede pa tong mga bracing guys na. Example, wala kay shear wall, no, dili ka mag shear wall, then naka tong mga bracing systems. So pwede to siya as stated. Nasamo to sa steel na mga kuan. Kani mga steel concentric braced frames guys. Kani po steel eccentrically braced frames. So pwede na siya. Okay, consider siya as building frame system. So C, moment resisting frame. So mao ni siya ang isa sa pinakasikat, no, or mao gyud ang typical na ginagamit diri sa Pilipinas. Okay, ani moment resisting frames. Okay, so moment resisting frames resist forces in members and joints primarily by flexure and rely on a frame to carry both vertical and lateral loads. Okay, so mao na siya guys. flexure gid no, flexure ang iyang resist no, kay nagi mga beams no, normally ang magkuan gid sa kuan is beams na beams, columns no, kana na mga members ang mayon taog frames. Then dapat ma-resist nila both vertical and lateral loads. So lateral loads are carried primarily by flexure in the members and the joints no. Pasabot sa joints is joint between column and beam no, kana siya muna yung joint. So that's why sa moment resisting frame, aside from designing adequate beams and columns, so consider po ang joints. So theoretically, joints are completely rigid. Okay, so gahi gina siya. No, kay during earthquake guys, kasagaran ang joints gid ang kuan, ang tirahon no. Ang joints ang tirahon sa earthquake no. So moment resisting frames can be constructed of concrete, masonry, or steel. So there are 5 types of moment resisting frames. First one is money karon guys, money ang sikat karon kani. So special moment resisting frame or SMRF. So that is both for steel and concrete, pero more ang daghan sa seminar karon guys is kaning concrete. And hopefully sa inyong steel design ay sa inyong RC, so na-discuss ni sa inyo ha kaning SMRF para makabalo pud mo unsa ni siya. Okay? So masonry moment resisting wall frames, naputay concrete intermediate moment resisting frame, steel or concrete ordinary moment resisting frames. So nana sila yung mga kalahian guys no. Though dili kayo dyan ako ma-elaborate kayo kung unsa dyan ang specific na difference. But from its mga wordings guys, parehani kung example ordinary no, kana ordinary moment resisting frame. So kana siya is kato na siya mga typical na to ang pag-solve sa RC no, kanang wala kayo yung mga dili kay dagko ang loading ana. Okay? Pero kung dagko ng loading guys, then kung nata sa high risk no, or high seismic risk, so normally gina-advise na special gid siya, special moment resisting frames. Kaya nani siya yung mga codes guys no, na mga kuana ni mga sa detailing no, sa design no, so na siya yung mga bantayonon labi na sa pag-design sa beams, sa columns, sa joints no, daghan taog bantayan na ang pag-abot sa SMRF. Then abot tayo special steel truss moment frames. So these systems provide a sufficient degree of redundancy and have excellent inelastic response capacity. So mo ni siyang mo na mabantayan na to later guys na ang moment resisting frame is taas ang R. Okay, so taas ang R value. Because of these reasons na taas ang degree of redundancy or kanina na daghan og support no, daghan possible supports sa loadings. Then also mga sa inelastic response pod no na part no. Then special moment resisting frames are specially detailed to ensure ductile behavior and comply with chapter 19, chapter 22 of the UBC 97. So mo na guys no, itong mga kuan guys difference. So especially detailed yun no, mato ko ingon kanina di ba na yung mga detailing na dyan siya sarili na detailing, then kanipod gina-ensure po na niya na ductile gid ang behavior. Intermediate concrete frames with less stringent requirements designed in accordance with UBC 97 cannot be used in seismic zone 3 and 4. So though I think na ani kuan guys kaniyang giingon kay zone 4 beta no, zone 4 beta. So dili siguro tanan structure ang ginamin siguro niya ni guys is kana mga high rise na mga building, so dili na pwede intermediate moment resisting frame kay sa zone 4 biya is kusog ang ground shaking no, so kusog ang movement or acceleration sa ground. So pero mga 2 story siguro, 3 story mura pwede pa siguro no. pwede pa na exemption siguro ni. So stricto lang siguro kay siya gamay. Ordinary moment resisting frames are steel or concrete moment resisting frames that do not meet the special detailing requirement. No, so dili kailangan ng special detailing requirement. Ordinary resisting frames constructed of steel are restricted and used by this. So ang pasabot po na guys is kaning ordinary pwede ra na siya sa zone kung sa Pilipinas so fight na sa zone 2. Okay, duha man ta diba, zone 2 o zone 4. So pwede siguro ka mag ordinary o intermediate kung naka sa zone 2. Okay? Pero kung zone 4 kita guys, dito kita sa SMRF. So mo nang gina-advise rin. Pero kung ako guys kasagaran mag-design ko 3-story murag gina SMRF na nako eh. Ang 2-story murag pwede ra dili siguro. Pero tawagan ni no kaning SMRF. Ang 2-story fights ra ang beam no sa column murag kuan. Dili kay ma-achieve tong isa ka requirement sa SMRF sa columns. Daw sa detailing guys, pwede na i-adapt. No, pwede na i-adapt ang SMRF. Kung gusto mo, pwede man ta magkuhan lecture gamay sa SMRF. Pero it takes time, so dapat sa RC gito guys, no. So manin naong guys, no. Mamanin normally niya makita na naay beams and naay columns. Mamanin sikat dali sa Pilipinas. Okay, so fourth, no, ika-upat, dual systems. Now, dual systems have essentially complete space frames that provide support for vertical gravity loads and combine two of the previously mentioned systems to resist lateral loads. So, moment resisting frame acting in conjunction with shear walls must be able to resist at least 25% of the design base shear independently. So the systems are designed to resist the total design base shear in proportion to the relative rigidities. So dual system, kato guys, combination of moment resisting frame and the building frame system, no. Pareha pala ni na shear wall, no. Pero dapat guys, para matawag nimo siya as dual system, dapat ang shear wall nimo ma-resist niya 25% of the base shear. Okay? So, pasabot asa na butang ang 75% dito sa imong frame. Okay? So, dito sa imong frame na butang. Okay? So, tabangay no murag sharing of sharing of loads. Okay? Then E, so cantilevered column building systems. The cantilevered column building systems have single cantilevered column elements supporting beams or framing at the top. So these systems have a large portion of their mass concentrated near or at the top and are fixed at their bases. So design base shear is essentially applied at the top of the vertical base member. They are regarded as inverted pendulum type structures since they extend from a fixed base and have zero moment restraint at the top. So this system have essentially 1 degree of freedom and horizontal translation. So kanay na guys. Ito na gani uban ani guys is kanang so naay pwede sa taas na naay mga say mga 4-story. Then nala isa ka column jud, dako gyud na column. So mo na gitawag sa cantilevered no kay na fix sa ground. No kanipod guys. So example kung naay loading. Kana so mura ka na cantilever beam, di ba? So mura ka na siya. And then F is shear wall frame interaction system. To resist lateral forces, shear wall frame interaction systems primarily use a combination of shear walls and moment frames. So building frames that are part of the lateral force resisting systems are required to be concrete frames. Okay, so these systems are restricted to seismic zone 0 and 1. So para na ni sa one guys sa zones kung asa low ang seismicity. Okay? So G is the unidentified or undefined systems. Undefined structural systems do not fit into any of these categories. So the designer of such systems must submit a rational basis for the design force level use. So na yung mga inana guys, kana mga structures na murag wala na nakabilang dito. Na mga complicated na gamay. So sa undefined system siya mabilong. So nana na sa kuan designer no kung saan niya pag-defend ang iyang design, okay, with respect to the lateral forces and mga gravity loads. Okay, so mo nitong table guys. So this is a table from UBC 97, table 16 and so makita na to dere ang kato mga basic structural systems katong 7 kabuok. Then mga descriptions guys sa lateral force resisting system description. Then naapod ang R, no, nanadali ang R value guys, katong mega O, then height limits for seismic zones 3 and 4 in feet. So, i-times na ni guys, kani in feet ni siya. So, i-times na og 304.8 para ma-mm. Okay, so, mo na yung mga height limits na nimo guys. So, say sa bearing wall system, so say shear walls, then concrete ka, so mo ni mo ang value for R 4.5, then 2.8 ang omega O, then this is the height limit lang na magamit. Okay, so 160 ang limit. So unsay significance ni mga R guys later sa pag-solve na to sa base shear, nani siya sa formula. Okay, so dako ni siya effect guys, no? Dako ni siya effect later sa formula para pag-solve sa base shear. Base shear na ginatawag. Okay? Then kani maka-affect ni later sa I think sa pag-solve nato sa mga earthquake loads. Na specifically earthquake loads which is horizontal, no, horizontal earthquake. Then kato pong mga earthquake vertical. Okay. Ang earthquake bayaran guys is not only horizontal, no, dili na horizontal, no, di pa inana, kundi dili na po na vertical na movements. Then napod gani consideration for orthogonal effects guys, which is orthogonal effect is kana mga forces, no, na wala naglihok horizontal, wala po naglihok vertical, no, kana murag labay-labay siya ba, no, nalabay ang mga loads. So mo to orthogonal effect ang tawag. So kana guys, no, just follow the kuan. Then sa second, building frame system, so say sa shear wall gaban guys, say shear wall. Pero building frame system ha. So say concrete. So mahulog siya sa 5.5. Okay. So kana. Dalita sa moment resisting frame, no, sa sikat na portions. So SMRF, no, kung SMRF guys ang imong building, so steel and concrete is the same 8.5. And walay limit guys, no limit ang ang height, no, walay height limit sa zone 3 and 4. Okay. So ang ako nabantayan guys is sa UBC, the same ni sila, no, the same sila 8.5, pero sa NECP lahi ni. Okay, so makita na to niya sa NECP na kaning steel 8 lang na siya. Okay, so 8.5 kanang steel. Tila, to na tanawan later. Then kung ordinary lang guys, moment resisting frame, kung concrete 3.5 lang. Okay. 3.5. Then dual systems o shear wall, curved walls concrete with SMRF, 8.5 gyapon guys. Okay, so I think 8.5 ang dako na value dali guys, no? Murag kung maobserbahan ninyo, 8.5 ang pinakadako na value, then 2.8 at ang pinakagamay, no? Pero for moment resisting frame systems guys, ang pinakagamay is 3.5, no? Katong ordinary lang. Okay, so ordinary concrete lang. So kato. So nganong kaya unsa kaya reason guys nganong no limit, no? Since katulog na kay taas og kuan ductility, no, performance sa inelastic range na portion na, then daghan na taas ang iyahang degree of redundancy. So murag mo tong wala gilimitahan, na dili para sa uban na nay mga limitations, okay, ang kuan ang pag-construct sa cantilevered. Gamay gani kayo 2.2, then 35 lang ang limit, gamay kayo. Then for shear wall frame interaction 5.5, so 160. Then sa undefined, so wala sila gibutang kay naman sa designer gad. Then kato na yung mga pareha ni guys na yung mga superscript, so basahan na ninyo dali sa taas. Okay, so next sa NSCP ta guys, no? Sa NSCP kay mao man yang na ato ang kuan sa Pilipinas, so mao pod atong sundon jud. Okay, so nasa NSCP guys, na siya concrete, na siya steel, no? Duha na ako ipakita, no? Mao ni sa concrete, no? Concrete guys. Then atong 7 na pod, pero wala iyaha gani dali guys is I think wala na niya gi-appeal tong undefined system, no? Ang gidungag niya dali is I think kani dual system with intermediate moment frames. Okay, so mas gwapo ni dali sa NCP kay klaro, no? Kaya tuwag daw seismic zone 2, seismic zone 4, then in meters na ang height limitation. So mapansin niyo guys, sa zone 2 dili kay stricto, no? No limit jud halos, no? Kay di man kayo high seismic. Okay, so no limit jud halos. So except lang sa kani 950 sa composite partially restrained moment frames. Pero ang concern gina to is mostly sa Pilipinas na mag sa zone 4, so mga ginato ang kuan. Okay, so tanaw na to tong sa moment resisting frames guys. So sa steel, tanaw na to guys sa kani ay sa concrete rather, no? Sa concrete, so ang SMRF is 8.5, then 2.8. So the same na dito sa UBC. Pero pag abot diri sa steel guys, so steel na ta. So tong SMRF, so turo guys 8. Tapos nila ko ang kuan amplification factor 3. No, murag 2.8 po to ganina eh. Tara. 2.8 po ganina. Okay. So for steel, no, kay mamo na kasi atong ginagamit. So for concrete 8.5, then 2.8 amplification. Then for steel 8 lang siya guys, ng gamay. O 0.5. Okay na. Okay, so follow na nato NCP guys, no, kay mama ng setting na to dali sa Pilipinas. Okay, so dagdan lang steel guys. Yung dagdan kayo compared with concrete. Okay, so now regular and irregular structure. So isa po ni sa makakontribute guys, no, sa behavior sa structure nato during earthquake. Kung regular ba or irregular ba ang atong structure. So makita na to later na may mga irregularities vertically sa atong structure, and napod sa plano, no, depende po sa shape. Sige dato basahan na ta. So in designing a structure, selection of structures basic plans, shape and configuration is a critical step. So critical yun yung word guys, so critical step. So the decision will influence the ability of the structure to withstand earthquake, ground shaking, while configuration cannot be presumed to be the sole reason for building inadequacy. It is usually a significant contributor. So mo to guys, na mo tong isa sa kuha niya anong consider niya as critical step, no, kay isa po sa mga contributor gyud ng mga sa shape, no, o gyud sa pagplano. So previous earthquake performance of buildings clearly illustrated that all other parameters being identical, the simpler the building is, the better its seismic performance. No, mao na mas kung symmetrical mga ana, so mas lapo na siya seismic performance. Box type mga ana guys, mas dali na siya isolve. So regular structures in accordance with the UBC 97 are described as structures having no significant physical discontinuities in plan or vertical configuration or in their force resisting systems. So based on UBC 97, irregular structures are defined as structures having significant physical discontinuities in configuration or in their lateral force resisting systems. Okay, so mga na guys ha. So significant physical discontinuities. Okay, so mga na mga kuhan guys. Mga na ang murag associated sa irregular structures. So makadungog kag irregular structures, so discontinuities na siya, physical discontinuities. Then for regular structures, so have a uniform and continuous distribution of mass, stiffness, strength, and ductility with no significant torsional forces or large height width ratio or large changes in plan area from floor to floor. Okay, so muna guys ang regular structures. So they have relatively shorter spans than irregular structures, simple structural subsystem, and balanced stiffness and strength between members, connections, and supports. So the code permits static analysis for irregular structure with few exemptions. Okay, so pwede pa static analysis na guys pag regular ang structure. So again, nawaga po na yung mga considerations. So structures with regular shape, changes in mass, then from floor to floor, variable stiffness with the height, and unusual setbacks historically have not performed well during earthquakes. So muna ang mga kuan guys, na namang do yung mga studies yun, no, sa structures dati pa lang. So muna ilang mga basis, okay, nganong dili good pod ang irregular shapes. Pero again, na may mga analysis ron, design considerations na ginagamit, so diskarte sa engineer pod. So makakuan magapon na mag-go gyapon ang kuan ang plan na ilang gusto. So this is unfortunate from aesthetics and creative perspectives because such buildings are generally among the most pleasing in appearance and interesting to design. Okay, so mao gid no, ang uban man good para sa mga architects, so ambitious man jud kayo, no, gusto jud aesthetics then mga creative perspectives pod jud. Pero normally sad to say dili gid tanan pod, no, pwede makakuan, pwede ma-go. So mo nito mga kuan guys, vertical na guys, vertical regular structures ay nani good, no, straight lang. Then mga vertical irregular structures, so kana, so I think mga nana may mga buildings siguro na inani ran, no, so inyuhan ng research nito. Then in table 6.11 or sa table sa UBC 97 table 16-L and M, plan and vertical structural irregularities. No, for vertical guys, physical irregularity type, so stiffness irregularity or soft story. Then weight or mass irregularity, then geometric irregularity. Then also makita mo na to ang in-plane discontinuity, then kaning weak story guys. So ma-discuss mo na to na later. Then sa plan, napot tayo mga torsional irregularity, the entrant corners, diaphragm discontinuity, so out of plane offsets and non-parallel systems. Sige, ito na isa-isahan guys. Okay, so for vertical structural irregularities, so UBC 97 table 16-L lists and defines the following 5 types of vertical structural irregularities. So mao ni ang una guys, so soft story, mao ni ang typical no na mga problema karon sa buildings no sa Davao City pod nakatang during the earthquake. Kaning soft story kay sagaran dili ma-consider ba, no, dili ma-consider ang effect. So a soft story has a stiffness less than 70% of the story immediately above, or less than 80% of the average stiffness of the 3 stories above. So mao na ang iyahang more technical definition. Pero by just looking at the structure, kasagaran makuha na to guys, ma-conclude po na to na soft story siya, na siya soft story. So mao na yung mga sa pictures guys kani. So nakay building dira, then kani common ba din sa to, di ba, kanang taas ang ground floor, then ang kani taas ang height, no, taas ang height sa ground floor, then pag abot sa taas gagmayon. So asa man ni kanang mga condo, di ba, condos, mga balay pod na mga inana. Then kani pod guys, kaning inani walay column sa kuan, walay column diri maputol. Okay, kana no, walay column dira. So tanggal siya kay sa second floor na nag-start. Kay normally kung example sa mga architects, kung dili sila ganana na poste kay kuan obstructed ang space, kuan na patanggal. Kani pod guys, irregular ang height. So mga height diri mugbo, tapos mukalit og kuan taas kana. Then kani pod guys sa shear wall na part, so pareha ni shear wall sa shear wall, na shear wall, or I think opening siguro na. So bracing kana, bracing pero pabot sa baba wala siya na tarong, na wala na continue. So isa na siya. So mas klaro na guys, naka 3D. So kani stiff and strong upper floors due to masonry infills na mama na kay kana na mga walls guys. So makatabang man na sa stiffness sa imuhang kuan, sa imuhang floors no, sa building sa taas. Problema ni mas baba kaning walay mga walls, di ba? So kuan na siya, column lang. So I think makita niyo sa sa PS building, no, sa PS building guys, daw nato yung mga office doon ng gamay, pero murag matawag yapon siya as soft story. Okay, pero kanipod sa mga condo guys, I think sa mga condo, Magallanes residence, kay sa baba biya to is parking space, no, mao na ilang ginabuhat na yung mga parking space dala sa baba. So kana guys, no. Then kanipod mga inani, normally kana jud mga walay space sa baba, ay kanang walay mga walls, no, kana tas paabot sa taas na yung mga walls. Kana pod guys rawa discontinuous, no, wala i-continue ang column. So soft story caused by discontinuous column. Kani the columns in one story longer than those above. Kani guys, pareha ni guys, na kay column na rin, pero wala na magipadayon dito. Wala na magipadayon. So kana mga inana guys. Pero ma-consider man na siya no, na yung mga codes no, on how to consider soft story. So one of the example na ni guys, ako ipakita sa inyo no, the catastrophe sa kuan. I don't know kung sa Spain ba ni no, ang purpose ata niya ani is nagabaha man gud, no, nagabaha sa ilang lugar guys, no. Nagabaha sa ilang lugar. Tapos ibutangan niya ginana sa baba substory kay para ang tubig dili kasaka dito sa mga residents. Pero ang problema wala na consider og tarong ang substory. So mo ni nani during the earthquake. Second is a story has a mass irregularity when its mass is more than 50%, 150% of the effective mass of a story above or below. So roofs lighter than the floor immediately below are excluded. So exclude na tana kay kuan man dun na basta sa roofing gaan naman dun na compared with the stories sa baba. So mo ni guys, parehay na ni. Ana. So bugat no, paabot na rin bugat kayo. Kaya dali dili ka murag halos the same na sila, murag ana typical siguro na dala. Then sa taas bugat no. Kasi daghan kayong tao, ana gamit, ana storage. So kanay guys mga nani. So heavy mass. So na irregularity sa mass. Third, story have vertical geometric irregularity when the horizontal dimension of a story's lateral force existing system is more than 130% of that in an adjacent story. So one story penthouses are excluded. So money nani guys. Murag hagdan na no, murag hagdan na. So na irregularity sa geometry niya. Ana so contribute gyapon na sa performance during earthquake. So fourth is in plane discontinuity na exist at a story when there is an in plane offset of the lateral load resisting elements greater than the length of those elements. Okay, so kanay guys. So discontinuous ang shear wall. So dapat manggod kung na mag shear wall ka pila na sa baba. No, pila na dapat na shear wall. So kung nakay base, kung nakay framing dira pila na sa baba. No kay para gahi po na no. Kuan po na imo diri sa baba. Stiff po na siya. Okay. Then weak story. So weak story or discontinuity in capacity. So exist when the story strength is less than 80% of that in the above story na. The story strength is defined as the strength of all of the seismic resisting elements sharing the story shear and direction of the earthquake. So lahi ni siya sa substory guys ha. No kay pag mayon ka sa weak story, ang weak story is concern, ang main concern niya is the strength. Okay, so main concern the strength, then sa substory is the stiffness. Okay. So parehan guys. So since na may kuan sa baba, ay kung na mga walls sa taas. So parehan Pero murag gapon siya kuan guys na, murag gapon siya substory. Kay murag kung murag substory, so murag associated po siya with the weak story. No kay tungod taas ang stiffness ani diri. Then kani mga kuan naman ni siya diri, mga columns wala kayo stiffness, so for sure wala po kayo na strength siguro no, inana ang murag yang concept. Parehan guys kaning continuous ang yang shear wall pero pagabot dari walay shear wall, so na deficiency gamay no, kanina portion to nga mas taas ni strength compared with these two. Okay, so that's the time na weak story will exist no? And also with these conditions na given ka ng 80% guys. So mo to sa mga vertical guys, vertical structural irregularities. Next is a plan no, isa po sa plan no. So UBC 97 table 16-M so list and defines the following 5 types of plan structural irregularities. So first is a torsional irregularity. Consists when the maximum story drift caused by the lateral load, the accidental torsion at one end of the structure transverse to its axis is more than 1.2 times the average story drifts calculated from both ends. Only buildings with rigid diaphragms are affected by this types of irregularity. So, muna guys. The UBC 97 specifies that earthquake forces should be considered from any direction of other than the principal axis of torsional irregularity exists for both major axes. So, kani guys, para ni mga L-shape mao nang dili kayo advice din ng mga L-shape na L-shape na structures. So, para na guys kung naikuan force no, paina ng force nimo pana no. So for sure motuyok din na no, na motuyok na mo kuan maka-torsion. Mo nang torsional irregularity na ginatawag kana. So pasabot kung nakay column dara, duoy ganay mong column dara no kay murag kung tanaw nimo guys siya murag pivot point ha. Pivot point sa imong structure. So ayan pasabot na guys magka-torsional irregularity na once na kaning story drift dere and delta 2 is mo greater than sa 1.2 of the average of this story drift and this story drift here no sa tara na side. Okay, so torsional irregularity. Second is building has a re-entrant corner irregularity. So when one or more parts of the structure project beyond a re-entrant corner a distance greater than 15% of the planned dimension in the given direction. Okay, so mo to guys kanina no kung katong L-shape kanina, so concern siya atong sa story drift no or sa torsional irregularity, so maigo pud siya sa re-entrant corner irregularity katong ingon kanina guys kay murag siya mo ang pivot point no kani re-entrant corner. So magka irregularity kag inana once na kanina mga distances guys, so sa plano. So dito if this dito is greater than 0.15 of D1. Okay, so first condition for this side, no, for this side here sa vertical dimension, then napog ka sa horizontal dimension if ang L2 is greater than 0.15 of L1. So make sure na dili siya modako ana. Okay, so dapat ang imuhan dito less than 0.15 D1 para dili magka re-entrant corner irregularity. Okay? So kana siya. So these are the conditions guys na ma-experience nimo na irregularity. Okay? Re-entrant corner irregularity. Kato pag ganina guys kani po na condition kung ma-satisfy ni na condition magka-create og torsional irregularity. So make sure good na less than no, less than of the conditions na mga story drift na nandala. Okay, third, diaphragm discontinuity. So of course with diaphragms having abrupt discontinuities or variations in stiffness, including when there are cut out or open areas greater than 50% of the gross diaphragm area, or when the stiffness of the diaphragm changes more than 50% from story to adjacent story. So pareha ni guys. Sample mo ni mo L no, mo ni mong L, then mo ni mong D. Okay, so same mo nito yung diaphragm area na ginatawag. Okay, so if ang opening daw guys, ang opening area daw is greater than kanina area, kaning open na rin. Pag mula pa siya 50% sa imong LD, then that's the time that you will have this diaphragm irregularity, no? Then pareha po na guys. So kanipod, so napog kay L dara, then napog kay L dara, then napog kay D dara, no? L times D. So this is your diaphragm area. No, diaphragm area ni man sila tanan. Ang naitabo dali guys is kaning sa tunga mao na siya nagtunga ha. So L over 2 na siya. L over 2 then kana po L over 2 pa na. Kaya naitabo dali guys ang imuhang rigid diaphragm is more than 50% gina na kay dari mataman. Na naman dala taman kani. Ang mga rigid diaphragm is more than 50%, tapos pag-abot na rin i-flexible diaphragm nimo, so pasabot na ay discontinuity, no, from rigid to flexible, then sobra pa dyan 50%. Okay, so that's the time na nakakay discontinuity na sa diaphragm. Okay, take note guys, ang diaphragming is mura man na siya floor system nimo, no, sistema man na siya na which is kung naay earthquake, so makatabang na siya, no, makatabang na siya sa performance sa structure na ma-resist ang mga lateral loads ng diaphragm. Sige lang, try na to discuss ng diaphragm systems guys. Okay, so at least a glimpse of it na para makabalo mo. So sa flooring na guys, pag may diaphragm system, so more on sa flooring system na siya. Okay, so make sure that the opening area is less than, no, para dili ka magka diaphragm discontinuity. Then fourth one, an out of plane offset is a discontinuity in the lateral force path. An out of plane offset of the vertical elements. Okay, so this is a concern. Ang concern ani guys is sa vertical elements or sa column. Okay, so pareha ni guys, kung mo ni mong plano, kanina column is sa kuan na siya, first floor lang na columns, no? First floor lang na siya na column. So kani siya column from roof to second floor. Then kani siya is column from roof to foundation. So sa laing nasod man gud guys is nani ila ha, no, for example na kay framing, so mo ni mong foundation. Okay, so mo ni mong foundation plan. So foundation na siya guys ha. So say mo ni imuhang ground. Okay, so ground floor na siya. Okay, ground floor. Ang sa Amerika guys is kanidari first floor pa na sila ha. Okay, first floor. Sa tuwa mong good second floor na dito. Okay, so second floor na siya dili. Ang ilang ground, ang atuwa dali, di ba? Kaya ang ground floor mo first floor, tapos pag abot sa taas second floor na sa ilaha dili, no, first floor na siya. Then say this is your second, no? Second floor, then monitor mong roof. Okay, so kana siya guys. Say kana. So naitabo guys, kaning nasa front, no, kaning nasa front na column nimo is dali na nataman. O nara na dali taman. Okay, so first floor columns kana siya. Then kaning nasa sulod, so column from roof to second floor. So na siya dali taman. Da lang kana lang. Then katong imo na sa tumoy is from gid siya, from foundation to roof, no, from foundation to roof. So murag kuan imong building ani, kana murag sa zigzag something ana. Di na ako madrawing sa 3D guys, no. Tapos I try to imagine, no, the discontinuity of the vertical element. So mao na gitawag na out of plane offset, no, the discontinuity. And it will affect the performance of your structure during earthquake. So fifth is the non-parallel system. Is one for which the vertical load carrying elements are not parallel to or symmetrically about the major orthogonal axis of the lateral force systems. So this is includes buildings in which a column is part of two or more intersecting lateral forces resisting systems, so as would most likely occur in a corner of a column at the ends of two orthogonal frames. So unless the actual column load due to seismic force is less than 20% of the column allowable load. So one guys, example, laro na, no, from the word non-parallel. So the sides kay dili parallel. Kana, no? And dili gini mawasan guys, no, kay naay mga lote na dili gid box type lang. Naay mga lote na irregular gid siya. No, pero ang ginabuhat sa uban gyapon is kung mao na yung lote, so buhatan lang box type na pud dala, no. Sa sudod ana lang. Pero again, what if kung ipahurot ang lote? So that's the time na you will have to consider non-parallel systems. So, naapay mga irregular geometry, no? So, dili lang to sa vertical, guys. So, kani pod na gini siya sa actual pod, no? Di gina maiwasan. Kani nagi mga irregular geometries. Then, naapay mga irregularities sa mass gihapon, guys, no? So, di gihapon na siya maiwasan. Okay? Okay, pareha na mga split type, no? Split type na balay, guys. Kanang first floor, no? Example, first floor dari or one story lang. One story. Then, paabot dito sa pikas, mo 2 story. Ma 2 story siya. Okay, so mga inana. Ma 2 story. So, pasabot, mas bugat dito kay 2 story man to dito. Compared with the rest of baba. So, napay regularity sa mass and sa resistance. Okay, so those are the irregularities, guys. So, let us proceed sa ito ang example. So, sa ito example, 150 feet or 45.7 meter building structures in California are shown in the elevation. So, structure 1 has a reinforced concrete shear wall for lateral loads in one direction and a special steel moment resisting frame system in the orthogonal direction. Okay, so structure 2 has a combined special steel moment resisting frame with reinforced concrete shear wall in each direction, but the shear wall is discontinuous at the second floor. Okay, so first, what is the applicable response modification factor R for structure 1? For structure for B, how about for structure 2? Then for C, which if any of the building structures would be classified as irregular based on the UBC 97, and what are the implications? Okay, so this is a solution for structure 1. So katong sa structure 1, guys, is say kung ano yung mga structure 1, ang plano ana, so this is the plan view. Then nakay x and y direction, no? X and y direction. So say there is a x direction or kaning sa front side, no? So ang naadari is kaning reinforced concrete shear wall. Okay? So na reinforced concrete shear wall. Then kaning diri sa y axis is kanang SMRF, no? Kanang special steel moment resisting frame. Okay, so nanay na itabo. So, combination of two systems. So, pwede na siya, guys. Nana siya dari. So, structure 1 is a building frame system with concrete shear walls in one direction. Sa tuang ganina dari sa illustration sa x-axis. Then, sa pika, sa y-axis is katong special moment resisting frame sa steel. So, where combinations along different axes exist, na nagi na siya, hindi na siya maiwasan, guys, kay namagoy tendency na say mas kusog ang earthquake dari, no? Say mas kusog ang earthquake dari sa x compared with katong sa y. Okay, so motong ibuhatan siguro niya shear wall dari sa x, no, kay mas dako ang earthquake load sa x compared with the y, no, kay marang initially ang naitabuan ni, guys, initially siguro ang design ani is special steel moment resisting frame, tanan x direction. Pero upon checking the drift, no? Upon checking the drift, ang which is caused by a large seismic forces. So dako, no? Dako ang drift dara. Ang pasabot sa drift, guys, is kung monitor yung structure. So ato ang ikuha na. So kanamurang nahinana. Okay. Ay, wait. Kung mauna yung mga original structure, guys, kana. Then, nakay lateral force. Glimpse lang ni sa drift, guys, ha. So, pag tulak po na, for sure, ma-displace gana siya. So, nakay delta, dala. So, say, you have that delta displacement. So, dako kayang delta, guys. So, dako kayang delta sa x axis. So, motong iyahang gibutangan og shear wall dara. No, in order to lessen this drift. Okay, delta. So yun na ang possible or tendencies ng na combine. Okay, combined system. Then also UBC permits any combination of lateral systems for buildings less than 160 feet in height. So pwede pa guys. Pag less than 160. And restricts are only for systems in combination with bearing wall systems in one direction. So based on UBC 97, table 16-N, then we will get these answers, no? So katong RC or concrete shear wall guys is dito na siya makategorize sa building frame systems, no? Categorize sa building frame system. So R is 5.5, then special steel moment resisting frame is 8.5. So this is based on UBC 97, table 16-N. Okay, kani. So maumpuli siya nasa book yun guys. So try to follow. Pero I think na siya discrepancy gamay pakabot sa NSCP. Okay, so ako alay pakita guys. So mo nito sa NSCP. So dahil siya nahulog guys sa shear wall frame interaction systems sa NSCP sa 5.5. Then muna siya sa NSCP. So sa NSCP guys is 8, no, katong SMRF sa steel, no, sa steel ni siya guys na portion. So 8 guys. Then 5.5 siya dali. Pero I think try na to balik guys ha. Ang iyahamang ko dali is building frame system, no? Building frame system. Ito, tanawan balik. Building frame system. Mo niya guys itong answer niya. Then nabilang sa 2. Okay, so building frame systems, shear wall, then concrete. So ito na 5.5. Okay, so murag I think murag malit ako nakuhan guys. Malito ako na box sa NSCP. So kung building frame system siya guys, kung building frame system siya, so dapat tapos special man, murag special to guys eh. Okay, special man ang frame. So kung may yung special reinforced concrete shear wall, so 5 day dapat to guys sa NSCP, no? Sa NSCP na guys ha. Then, kung ordinary lang, 5.6. So, dili ka pong sakto ang 5.5 na answer niya. Okay? Pero, either of the two guys will do, I think. Pero since naka-special magod ang frame, so, I think, special na po itong gamitan, no? Special reinforced concrete shear wall. Pero ang ginabuhat na sa uban guys is kung special ang frame, then kung butangan lang yung shear wall, ang ginagamit sa uban is ordinary lang po. Okay? Kaya kung mo yung diba, pag mo yung special reinforce is nagini siya katong murag tong lahi-lahi na detailing, no? Murag inana. Pero dari sa to dili man kaayo gyud inana ka specialized pod ang pagkuan sa shear wall. No, kay it acts or magtabang raman na siya, mag-help to resist lateral force. So kung ako guys, kung ako mag-decide kaya wala magiging sa problem kung special or ordinary. Pero kung ako mag-decide, kaya na lang siguro ta. Ordinary na ta guys, ordinary reinforced concrete shear wall. Okay? So parts na siya, 5.6. And 8 ang kuan. NSCP na guys ha. Ang katong answer man god is based sa libro or sa UBC na guys, yeah. Sa UBC. So monitor sa UBC guys, special moment resisting frame. Then napakita na nako tong isa ka kanina katong sa 5.5. Then for structure 2, so a dual system, no? Dual system siya in both direction. So where combinations along the same axis exist, So the UBC 97 requires that the value of seismic modification factor R for design in that direction not be greater than the least value of any of the structural system utilized in the same direction. So based on again sa UBC niya guys, so special moment resisting frame niya ha, then reinforced concrete shear wall. R should not be greater than 4.5 less value of R for any of the structural systems, and the combined value of the seismic modification factor R 4.5 should be used. So kanay. So ano yan basihan guys kung sa NCP na setting. So 4.5. Okay, 4.5 then monitor sa SMRF ng Japan NCP. Then sa UBC 8.5. Katong special steel moment resisting frame. Na to balik guys itong sa kuan UBC na kuan. Okay. Mura same na lagi sa bearing guys kato 4.5. Okay, sa bearing wall system. And lastly is katong sa C, no, gipa-identify guys kung unsa ang irregularity. So I think ang naala irregularity is katong sa structure 2. Okay, so based on UBC 97, irregular structures bear significant physical discontinuities in configuration or in the lateral force resisting systems. Structure 1 is a regular structure. So based on given information and visual observation. So more on physical na guys no, mga physical irregularities na ito ang ginatanawan dali. Then while structure 2 it has vertical irregularity. So the observed irregularities are stiffness or substory and in plane continuity in vertical lateral force resisting elements, no. Okay, so kanay guys, so makita na to substory, no. Substory, then ang iyang shear wall pod wala niya gi-continue dali. So mo to katong in plane, no. Mo tong in plane discontinuity, no, kay wala gi pa dayon tong shear wall. Then sa stiffness pod substory tong sa baba. By inspection, the first story of structure 2 is considered a substory. So based on UBC 97, a substory's lateral stiffness is less than 70% of that in the story above or less than 80% of the average stiffness of the three stories above. Also, it can be seen that the vertical lateral force resisting system is discontinuous. Okay, so according to UBC 97 table 16-L, this irregularity is categorized as an in-plane discontinuity. Then the UBC 97 requires concrete, masonry, steel, and wood elements existing shown columns supporting such continuity systems have to have the design strength to resist the special seismic load combinations. Okay, so mo to mga irregularities guys na ato nakita, and these are the implications, no, na dapat i-address. Okay. So those are the guys, no, mga irregularities, no. Mga dunga guys katong R factor, tong omega O factor, then mga irregularities. Okay, so expect for part 3, no, kato na mga sa solving na part na guys. So at least na consider na nato tong mga factors, mga parameters na tong gamitan later to solve base shear. Okay, so that's all for now.